So box number 19 is parallelogram properties. So we've kind of gone over these in previous notes, which is why now we just kind of have pictures and no pictures, I mean. But I still want to draw a picture for you guys because if you're like me, you don't like to just stare at words. So parallelogram. A parallelogram is a quadrilateral with two pairs of parallel sides. So I'm just going to draw my somewhat decent parallelogram. It's good enough. There we go. Here's a parallelogram. In this parallelogram, you know that two pairs of opposite sides are parallel. So this one is parallel to this one. And this one is parallel to this one. So the opposite sides are parallel. The two pairs of opposite sides are congruent as well. So in addition to being parallel, they are congruent. That means they have the same length. So the two blue sides have the same length. I'm not going to make more marks on it. It's just going to look messy. But know that the two blue sides are the same length. And then the two yellow sides are the same length as well. There are two pairs of opposite angles that are congruent. So this angle and this angle, they're opposite, they are congruent. That and that, those two are opposite, they are also congruent. And then the consecutive angles, same side interior angles, are supplementary. So I'll just circle them, I guess. Like these two are supplementary, or you could also say these two are supplementary, or you could pair them up like this or like that. Now that looks messy, so I'm going to get rid of all these circles, but the point is the two angles that are right next to each other, they're going to be supplementary, which means add up to 180. Okay? And then last but not least, the diagonals bisect each other. So if I draw in some diagonals, I can't talk, diagonals like that, those two green lines, they bisect each other. That means they cut each other in half, perfectly in half. Any questions on box number 19? Okay, let's do box number 20 then. A rhombus. A rhombus is a quadrilateral with four congruent sides. Let me draw you a rhombus. It's like a diamond, okay? Kind of, yeah, kind of looks like a diamond. Oops, that's very not straight. You know what, I can't draw a straight line today, just let it be. A rhombus is also a type of parallelogram. It's just that specifically for this type of parallelogram, all four sides are equal, okay? It has four congruent sides. So it's like you took a square and you just kind of smushed it a little bit. You just tilted it to the side. So all four sides are congruent. Just make sure I mark that. In a rhombus, the two pairs of opposite sides are parallel because, like I said, it is a parallelogram of sorts. So those two are parallel and these two are parallel. All the sides are congruent. We already said that. Two pairs of opposite angles are congruent. So just like any other parallelogram, because this is a type of parallelogram, those two purple angles are congruent. Just like those two purple angles are congruent. The consecutive angles, same side interior angles, are supplementary. So once again, that just means that you can pair up any two that are right next to each other, like those two are right next to each other. They are supplementary, which is adds to 180. And you can pick any other two that are right next to each other. Like I could have picked those two because they're right next to each other. Those are also supplementary, they add to 180. Okay. The diagonals bisect each other, so let me draw the diagonals of this. These two lines cut each other perfectly in half. Okay, so that's a diagonal bisecting each other. The diagonals also bisect the corner angles. So if I zoom in more over here, I guess I shouldn't zoom in that much. If you look at this corner, that purple angle got cut exactly in half. zoom in over here. Oh no. I don't need you, Siri. Okay, my bad. If you zoom into that angle on the bottom, this one, okay, it also got cut in half. This one got cut in half, and that one got cut in half. Last but not least, the diagonals are perpendicular, so there you go. I just put a right angle there. So the rhombus properties have everything that a parallelogram has, but a little bit more because all four sides are equal, so a little bit more special. Any questions on this one? Hopefully this feels a little bit like review because we learned about these shapes before. If you guys have any questions, feel free to interrupt me, but for now, I'm just going to keep going. Let's go to box number 21. Proving a quadrilateral is a parallelogram. So if we want to prove a quadrilateral is a parallelogram, we need to show that one of the following is true. We have two pairs of opposite sides are parallel. So that's one way. Another way is to show that two pairs of opposite sides are congruent. So if you say that, well, we'll do examples later. Let me just read these to you. Two pairs of opposite angles are congruent, or one pair of opposite sides is both parallel and congruent, or the diagonals bisect each other. So if any of these things happen, then you can prove a quadrilateral is a parallelogram. So there's 1, 2, 3, 4, 5. 5 different ways you can prove a quadrilateral is a parallelogram. Okay, and we're going to put these into use later. Let's go to box 22. Parallelogram congruent parallel side theorem. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So that's literally just this one. It's just that one bullet point got pulled into its own box because we're going to use that one a lot. So any questions on these two boxes? Okay, let's do the next box. We have isosceles trapezoid definition. So a trapezoid is a quadrilateral with exactly one pair of parallel sides, that being these two, those are parallel. And an isosceles trapezoid is a trapezoid with two congruent legs. So these, let me do it in a different color. These are your legs, and if they are congruent, then you have an isosceles trapezoid. Questions on that one? Okay, let me just note that in any trapezoid you have pairs of base angles. So these two that I'm marking in purple, this is one pair of base angles and they are congruent to each other. These are like one pair of base angles. And then there's also these top ones. Those two green angles, they are also another base pair or another pair of base angles. So in total, the trapezoid will have two pairs of base angles. Questions? Okay, let's do the next one. Isosceles trapezoid properties. Let me just zoom out because I think it would be nice to have a picture. So there we go. In an isosceles trapezoid, you know that one pair of opposite sides are parallel. Those are the ones we marked in yellow over here. The legs are congruent. So those are the blue legs that we have over here. They are congruent in the isosceles trapezoid. The two pairs of base angles are congruent. So the green angles are congruent as well as the purple angles being congruent. The diagonals are congruent. Okay, so I haven't drawn diagonals. I'm just gonna draw my own isosceles trapezoid here because I don't want the picture to get too messy. Okay, so there's my isosceles trapezoid. Let me draw in the diagonals. Here we go. So these are our diagonals and they are congruent. So the two blue lines have the same measure. They are the same size. And then finally, the same side interior angles are supplementary. So that means if you do, let me circle them. Okay, I'll circle them in yellow. I was deciding. Like these two, they're the same side, like they're both on the left. These are supplementary, so they add up to 180, okay? And same thing with the right. So these are on the same side. If you add these up, they add up to 180, okay? So that's only for the ones that kind of are on the sides, okay? You cannot, do not pick like these. These are not same side. Literally one is on the left, one is on the right. So this is not what we're looking for. So it's specifically the same side interior angles are supplementary. Any questions on these two boxes about isosceles trapezoids? Okay, let's go on to the last box. We have kite properties. A kite is a quadrilateral with two pairs of consecutive congruent sides. So if you know what a kite is, like in like the toy, like in general, a kite, let me just draw you one. This is a kite, okay? And it's a quadrilateral, so four-sided shape with two pairs of consecutive congruent sides. So like these are congruent and those are congruent, okay? So that's what I meant. Okay, so about a kite, the diagonals are perpendicular, so let me draw in the diagonals. I'll do them in yellow. Here are our diagonals, and they are perpendicular, so they make 90 degrees. Second thing about a kite is the diagonal connecting the non-congruent angles bisect the, wait, I can't read that. The diagonal connecting the non-congruent angles bisects the diagonal connecting the congruent angles. Okay, so let me redo this in a different color. The diagonals connecting the non-congruent angles, that would be this diagonal. Okay, so the purple diagonal bisects the diagonal connecting the congruent angles. It bisects the yellow one. So the yellow diagonal gets cut in half. The yellow diagonal is the one connecting the congruent angles because if you look over here at this and that, those are congruent angles. So that yellow diagonal gets cut in half by the purple diagonal. That's what that number 2 means. And last but not least, the diagonal connecting the non-congruent angles bisects the vertex angles. So this one, this purple diagonal, it bisects, what color have I not used? I'll just use green. It bisects the top and the bottom angles. So those top and bottom angles, they're not equal to each other, but the purple line will cut them directly in half. Oh. And those, the top and the bottom angle, those are your vertex angles. All right. Any questions on the kite? Okay. Remember that at any point, if you have a question, make sure you ask me, but it doesn't sound like you guys have any. So I'm going to end the recording.